My dear friends, welcome back to B Spice. In this session, we'll talk about a ruptured disc. This is one of the very long pending item. In fact, one of our viewers asked for it. So I took some time actually. Yeah. So we'll learn what is a ruptured disc and what is the types of ruptured disc and what's the application where we are using and how we are using all those we will dive deep. Okay, right. So basically, okay, friends, overpressure may occur due to what? Thermal expansion, equipment failure, control aspect failure, misoperation, or external fire. I hope you agree, right? So a rupture disk is a non-reclosing device actuated by inlet static pressure and designed to function by bursting of pressure containing disk. That's it. So here you may ask, what is a non-reclosing? Yeah, once it bursts, means that's all. It will not come back to your original. So that's all. It's like a use and throw, non-reclosing device. I'll explain that also in the later. Okay. So this is the point. So the rupture disk in a simplest form is a mechanical membrane. Okay. That held between flanges. I will explain that in the next slide, how it is held between the flanges and is designed and manufactured to burst at a predetermined pressure and corresponding temperature. That's it. So this is about the intro. I hope you are okay with this, right? Okay. Now I'm going to explain this rupture assembly. So this is your rupture disk. This is your outer holder and this is your inner holder. So this guy will go here and this guy will be inside, clamped inside. So this is the typical rupture disk. That's why I said clamped between two flanges, right? Yes. So this is the look and feel, right? Now, features. A rupture disk have a one-time use membrane. That's what I said. One-time use membrane, meaning once use and throw, that fails at a predetermined pressure, either positive or vacuum. So a rupture disk provides fast response to an increase in system pressure, but once membrane fails, it will not receive. That's it, right? Once broken means broken, it will not receive. A rupture disk is just another pressure relieving device. So it is used for the same purpose as a relief valve to protect a vessel or system from overpressure that can cause catastrophic failure or even a death. Okay. So these are the features. I hope it is clear. Right. Now I go into the concept like when to use. See, as you see here, friends, this is your vessel. So this is your nozzle and this is your rupture disc. So it is clamped between the two flanges, right? Okay. So maybe before going into when to use, I want to touch upon a bit. Okay. Rupture disc costs less than the relief valves. Okay. So I'm going to explain that relief valve in the next slide. Okay. So they generally require little to no maintenance at all. A rupture disc is a non-reclosing device, meaning once break, it's over. Okay. Which means once it open, it doesn't close. Okay. So rupture discs are extremely very fast acting. Okay. So these are the basic features. Now I'm going to explain with a bit of a scenario, right? See here, you have a rupture disk and you have the PRV. So meaning here, the rupture disk is upstream of the PRV. PRV is in the downstream side. Okay. So this is the upstream of the PRV. Alternatively, we can also have the downstream also. I'll explain that both in the subsequent slides. Just understand that system contents can plug the relief valve during relief. See, for example, here, something is there, the system content. So if this is not there, okay, then this will directly go and, relief, it will, what you call, plug the relief valve. So during that scenario, you have to go with this rupture disk first. Install a rupture disk upstream of the relief valve. Okay. And of course, for high viscosity liquids, we can use this. So this is the basic outline actually. Now I'm going to answer when we use this, how to use this. Okay, there are two scenarios. Stand-alone a rupture disk is used when we are looking for a capital and maintenance saving. So we will use only this rupture disc without this PRV. This will be directly mounted and you don't see this assembly. Okay. So that when we are going to go with this option, when we are looking for some cost savings, okay, then we can afford to lose the system content. So meaning this guy can go out, so it will not harm anything. So that time we can go with this option, standalone option. And the other option, the system contents are relatively benign. Benign means not harmful. Okay, not harmful. So when we need a pressure relief device that is fast acting, I want a very fast action. So that scenario, I go with the standalone rupture disc, only this portion. Okay, I will not go with this relief. Okay, so okay, good, clear. Now, and of course, one more. A relief valve is not suitable for the nature of the system content. So that time also we can only go with this option. So this is a standalone. Now I'm going to explain the other option. Relief disc, rupture disc in combination with the relief. Okay. So this option will be used, when we need to ensure a positive seal of the system. So this positive seal should be maintained. So that time we need to go with this combination. And the system contains solid that may plug the relief valve over time. The system contains solid that may plug the relief valve over time. So we have to go with this both option. Then of course to save money in the sense, the system is corrosive. The rupture disc is specified with more exotic and corrosion resistant material. So that time also we have to go with this option, because if it is corrosive and if you are not having this and you have only this, content may affect this also. So that case, in order to save cost and money, you have to go with this option, sir. So now I hope you have both options, right? Standalone and the combination of rupture disc with relief valve combination. Right, good. Now we go into the construction. See, standard material of construction are carbon steel and sometimes stainless steel for corrosive. So if it is more corrosive, the corrosive means, then we go with Inconel, Monel, aluminum, nickel, Hastelite, B and C. And less commonly used, very rarely, very highly corrosive, maybe we can go for gold, titanium, platinum, silver, like that. Okay. So this is about the construction. Now we go into the application. Two aspects, three aspects: mounted directly, mounted upstream, mounted downstream. Okay, so now mounted directly on equipment. So when we will mount directly the rupture disc directly on the equipment, the rupture disc may be used to relieve an inexpensive inert material to air if the loss pressure can be tolerated. Loss of pressure can be tolerated. So we can use directly without any relief mechanism under. Okay. Then at the other extreme, rupture disc may be used to vent highly toxic, poisonous, or corrosive materials to a flare header. It's not directly to the atmosphere, to the flare header. So that time we can directly mount this equipment. Then we have this option. Upstream of relief valve. This is what I explained. This rupture disc upstream of the relief valve. Okay, relief valve is the downstream side. So being mounted upstream to relief valve is a very useful application for the rupture disc. Under normal condition, this gentleman is sealed tight, protects the relief valve from being contacted by the corrosive nature of the liquid or medium, the plugging and hazardous or regulated process. So if the maximum allowing pressure exceeded, working pressure exceeded, the disc will break and the relief valve will start to relieve the pressure. Okay. As the pressure drops, the valve will shut and reclose the process. Right. That is the relief valve mechanism. But this guy already gone. So now we can have the best characteristics of both the devices, meaning the rupture also utilized and relief valve also utilized. So this is about upstream of relief valve. And one point I want to mention here, as a rupture disc is a differential pressure device, it is important to prevent the buildup of pressure between disc and the relief valve. So between the disc and the relief valve here, right? So how this is accomplished? Use of a pressure switch or a pressure gauge. Okay, we can use a pressure switch or pressure gauge here. Right? So this is about the upstream. Now Downstream of relief valve. Okay. So a rupture disc downstream of relief valve may be desired when valve discharges to a vent header that might contain corrosive vapor. You got it, friends? Yes. So maybe I'll go back here, downstream of the relief. Okay. So that is what I'm explaining here. A rupture disc downstream of relief valve may be desired when a valve discharges to a vent header that might contain corrosive vapors. So if the conventional relief valves are used, then precaution should be taken to prevent the buildup of pressure between the relief valve and the rupture disc due to valve leakage. This also we need to take up. So for this, in the earlier one, we have used pressure switch or pressure gauge. But here, we can use a bellow sealed or pilot operated valve whose set pressure unaffected by the accumulated pressure between the relief valve and the disc. So these are the mechanism, friends. I hope you are clear. Now I go a little bit away from this, I mean, not little bit away, but yeah, some add-on information. Okay, categories. There are many categories. Okay, we are saying ruptured disc, that is fine, but there are different types and categories, right? Yes, forward acting. So this is a forward acting. Okay, so forward acting disc are pressurized on the concave side of the disc, concave side of the disc. Okay, such that the material in the dome, the material in the dome of the disc is subjected to tensile stress. So flat disc, sometimes flat disc also is considered as a forward acting. Forward acting rupture disc can be rebulged, composite, scored, flat, and graphite. Okay. So these are the things. Okay, friends, we got it? Yeah. So basically, what is the pre-bulge means? It will be bulge, and composite means a different material, and scored means like this. As you can see here, it will be like a some kind of design. This is a scored actually. Okay. So now I go into the reverse acting. The reverse acting disc are pressurized on the convex side. There it was concave, and this is convex actually. On the side of the disc, such that the material in the dome of the disc is subjected to compressive stretches. Compressive stretches. Okay. So that is the thing. Yes. Yeah. As the burst pressure rating of a okay, maybe I'll go back here. Yes. So flat discs are considered to be forward acting. Yes. Here, the concave side of the disc is subjected to tensile stress and tensile stress. But here, the convex side of the disc is subjected to compressive stress. Compressive stress. That's it. So as the burst pressure rating of a reverse acting type disc is reached, the compression loading on the rupture disc causes to reverse, snapping through the neutral position, causing it to open by a predetermined, you see the knife edge penetration, yes, or a scoring pattern. You can see here, this is the called as a scoring pattern of knife edge penetration. Just it pop up, right? Buster. So that is the reverse acting. Now, solid type design, early rupture disc, were pre-bulged solid metal disc that burst in tension and could release a metal fragment in the system. So that is the point. If it is a solid type means when it bursts, it releases a metal fragment in the system. So that will actually prevent relief valve from reseating or may cause damage. So we need to be very watchful. That is about solid type. Then we have a score type. Score type, of course, a newer rupture disc design protect against either by tension loaded score or slotted metal disc, reverse buckling disc with knife edge cutter, which I mentioned, right? Yes. So, or reverse buckling disc that are pre-weakened, meaning scored lines. Some design is there, right? Scored lines. So they burst up. So they burst will full opening without any fragmentation. So the point is in solid type, we have the fragmentation, metal fragmentation. But here there is no such fragmentation. Just remember that. That is enough. Okay. Right, friends. So now summary also I want to give you. Like forward acting design provides a satisfactory service life when operating pressure are up to 70% of the mark burst pressure of the disc. Reverse acting design provides a satisfactory service rate when operating pressure up to 90% of the Mach bus pressure of the disk. This is just a rating actually, performance, right? So solid design results in relief of metal fragments, which I highlighted earlier, which could damage or prevent the relief fall from reseating. So we need to avoid this. Then score design will not release any metal fragmentation and as they burst along the pre-weekend or slotted score lines. That's all, friends. I just want to, give some insights on this rupture disk. So that is the intent of this video. I hope I have actually, achieved that target. So I hope you also, feel the same, what do you call that? In line with me, with my understanding. So if it is so, you can show your support, friends, either way by pressing the thumbs up button or maybe by subscribing. And I request actually, if possible, share with your friends so that it will reach many people. And my intention of uploading and sparing time, all these will be rewarded. That's it, nothing else. Thanks for the support. I'll see you in a very other interesting videos. Many interesting videos are coming up. So stay tuned. Take care. Bye-bye.